I'm back. I am Engineer Jewel Ryan Nicole Birriosa, and I will be discussing today about conic sections. So in dealing with conic sections, so you will be familiarized with different terms, but here are the most vital terms in relation or in studying conic section. So we have here cone, circle, ellipse, hyperbola, parabola, and eccentricity. So in general, you can create a circle, ellipse, hyperbola, or parabola, or conic sections by cutting section of a cone. So for example, we have here how to create a circle. So by cutting a plane, so a plane perpendicular to the base of the cone. So for example, we have here the base of the cone, and then you cut a plane perpendicular to that base, so you will be creating a circle. And then for the parabola, so if you cut a plane wherein if you cut a certain cone by a plane parallel to the element, so the element is here. So parallel to the element, so you will be creating a parabola. And then how to create a hyperbola, so cut a plane or by cutting a plane parallel to the axis. So here's the axis of your cone. So you will be creating a hyperbola. So assume I draw a straight line there. So again, how to create a circle. So cut a cone. So by cutting a plane into a cone parallel to the base of the cone. So you will be creating a circle. So if it is parallel to the element, so you will be creating a parabola parallel to the axis. If you cut a cone by cutting a plane into a cone parallel to the axis, so you will be creating a hyperbola. And then you will be creating an ellipse. So kahit saan po kayo mag-cut dyan, provided that you will not be cutting it parallel to the base, you will not be cutting it parallel to the element, and you will not be cutting it parallel to the axis. So you will be creating an ellipse. And also that for the eccentricity naman, so we will be that is also one way of determining or identifying what is a specific conic section. So next we will be discussing about eccentricity. So first that we discuss is by cutting a plane. So again, pag kinat mo, cutting a plane, pag kinat mo siya parallel to the base of the cone, so you will be creating a circle. Parallel to the element, you will be creating a parabola. Parallel to the axis, you will be creating a hyperbola. So next, we will be proceeding with eccentricity. For the eccentricity, as I have mentioned earlier, we can also determine what specific conic section is presented by the eccentricity itself. So if we are given with eccentricity which is greater than 0 but less than 1, so that is an ellipse. And then if we are given with an eccentricity which is equal to 1, so that given conic section or conics is a parabola. And then if the eccentricity is greater than 1, that is a hyperbola. If the eccentricity is equal to 0, so that is a circle. Another property that we have here for the conic section is what we termed as the latus rectum. So the formula differs for different type of conic section. For the circle, so the latus rectum is automatically its diameter or twice the radius. In parabola, it is 4 times the focal length, wherein the focal length is A. So that means it is 4A. And then in an ellipse, the formula is 2B squared over A, where A is half of the measure of the major diameter and B is half the measure of the minor diameter. Presented here is the general equation for the entire conic sections or conics. We have your ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. So this general equation or the mentioned general equation describes conic sections whose principal axis or axis is not parallel to the coordinate axis such that b is not equal to 0. So, I already mentioned earlier that we have different ways on how to determine a conic section. So, first that we discuss is by graph or cutting plane. And then second is by eccentricity. Now, we will be dealing with the value of their discriminants. So, the discriminant, so based on our quadratic equation formula, the discriminant is b squared minus 4ac. So if the value of the discriminant is equal to 0, so that means that your conic section is a parabola. And if the value of the discriminant is greater than 0, that means that is a hyperbola. And if the value of the discriminant is less than 0, and take note, we have here two conic sections wherein they are both fit with the discriminant wherein the value is less than 0. So we have here ellipse and circle. The only difference is if A is equal to C, so that is a circle. And then if A is not equal to C, so that is an ellipse. Okay? Again, if A is not equal to C, that is an ellipse. And if A is equal to C, so that is a parabola. That is a circle. So, again, if the discriminant is 0, that's parabola. If it is greater than 0, that is hyperbola. If less than 0, we have two conditions. That is either an ellipse or a circle. If A is equal to C, that is a circle. If A is not equal to C, that is an ellipse. So the value of A, B is and C is based on our general equation that I have mentioned earlier. Now we will be proceeding for the general equations and standard equations of each specific conic section. So let us start with circle. So again, as I recall, the value of the eccentricity of circle is 0. And we have here the general equation ax squared plus ay squared plus dx plus ey plus f is equal to 0. As you can see, this is quite related or quite the same with the general equations for the entire conic sections that is mentioned earlier. As you can see, we have here instead of cy squared, so we have here both value, which is a is equal to a. So again, I already mentioned earlier that for circle, so usually or generally, a is equal to c. So to avoid confusion for the general equation, instead of putting another constant, which is c, so we just use a since a is equal to c for circle. So we have here two standard equations. So as a tip, kindly memorize, or if you have to memorize, so just memorize this one, the one with center at hk, wherein the formula is x minus h, so the quantity of x minus h squared plus y minus k squared is equal to r squared. So since if the center is at the origin, so you can just omit the h and k here, wherein if you omit h and k, so you will be adopting to this, or you will be having another equation, which is x squared plus y squared is equal to r squared. So common misconception with this is the r squared. If you were asked to determine the diameter, so you have to get the value of r and not r squared. And also, since the square root has two values, the positive and negative values, so you will be utilizing the positive values only since we are talking about measurement here, or the radius. So there is, obviously, there is no value or negative value of the radius. So now we will be proceeding with ellipse. So here's some important details or notes about the ellipse. So for the ellipse, we have the value of eccentricity, which is C over A, or you can compute also that for, or A over D, wherein we have also the length of major axis 2A, and then length of minor axis 2B. So distance between directrices 2D, and distance between latus rectum 2b squared over A, and focal distance is a squared minus b squared is equal to c squared. So take note that the formula is a squared minus b squared is equal to c squared. So others are treating this as Pythagorean theorem, which is a squared plus b squared is c squared. So that is wrong. So please take note that the ABCD, the values of ABCD there is different from the ABCD here, or the ACD provided here in the general equation. So the values there will be derived from the standard equation. So in the standard equation, as you can see here, you have small letter A and then small letter B, and then you have the formula in which you can get the value of C, like that, and then eccentricity, like that. So the general equation for an ellipse is ax squared plus cy squared plus dx plus ey plus f is equal to 0. Take note that we use another constant C or another coefficient C here because based on our definition, in circle A is equal to C, but in ellipse A is not equal to C. So as you can see, we almost have the same general equation. We just change the A of the circle to C. And again, I am recommending you to memorize the formula wherein the center is at HK, and then if the center is at the origin, so just omit the value of H and K. So as you can see here, our formula is x minus H squared over A squared plus the quantity of y minus K squared over B squared is equal to 1. So this is center at HK, wherein the horizontal, at the horizontal major axis. The major axis is at the horizontal part. So when the center is at the origin, so you just have to omit the value of H and K since this is 0, 0. So you will be arriving at this formula. Yan. So same, we have another set of standard equation here, wherein the major axis is in the vertical axis. So again, I just recommend you to memorize or be familiar with the standard equation wherein you have a specific coordinate HK in the formula, and then if the center is at the origin, so you just have to remove H and K since the value of the center is 0, 0. So now we will be proceeding with parabola. So at the end of this lesson, I will be giving one example for parabola, one example for ellipse, and then one example for circle. And for the hyperbola, so I will be creating another video for that or another lecture, but our main focus for this conic section is circle, ellipse, and parabola. So next output, C, hyperbola. Yan. So again, just a recall, the eccentricity of parabola is 1, wherein our formula for the latus rectum is 4a or 4 times the focal length. So we have here general equation wherein we have here the vertical axis and horizontal axis, and we will be having next slide are the standard equations. So again, these are the equations wherein the origin or the vertex is at 0, 0 or at the origin. So again, I am recommending you to be familiar and memorize this one, which is the vertex is at a specific coordinates wherein it is hk. So if it is opening to the right, so your formula is y minus k squared is equal to 4a times x minus h, wherein if it is opening to the left, so your equation at the right side is having a negative value. So the same as with the upward, for the upward, so the formula or the equation is x minus h. So the quantity of that raised to the second power is equal to 4a times y minus k. And then if it is opening downward, so there is a negative sign or negative value in your left side. So take note that the value of 4a is the latus rectum. So that is, and then a is the focal length. So that is one of the most important parts or components of parabola in order to graph it and in order to visualize your solution. Let us proceed with the sample problem. So for the first problem, we will be dealing with circles. So the question is, give the coordinates of the circle center and its radius. So we will be having two final answers here. So one for the center of the circle and one for the radius. So the given equation is here. The quantity of x minus 2 squared plus the quantity of y plus 9 squared is equal to 1. So again, I encourage you to be familiar with the equation which is the center or the vertex is at specific coordinates which is hk. So for the circle, we have the formula the quantity of x minus h squared plus the quantity of y minus k squared is equal to r squared. So we can get the value of the center hk. So that is 2, negative 9 because the value of negative h is equal to negative 2. So h is equal to 2. The value of negative k is equal to positive 9. So k is equal to negative 9. So we have the value of the center. So we now look for another value which is the radius. So as you can see here, the radius is equal to 1 or r squared is equal to 1. So that is again the common misconception. Some of the students are answering the radius as the value of the r squared, but we are talking about or looking at the value of the r only. So r squared is equal to 1 or r is equal to positive negative 1 or r is equal to the square root of 1 wherein the square root of 1 is positive or negative 1. But again, we will be utilizing the positive value only since we are dealing with measurement or radius. So there is no negative radius. So for this example or for this problem, our answer is 2, negative 9 and r radius is equal to 1. For the second sample problem, we are dealing more about with the concept of parabola. So the question is, find the vertex and focus of the parabola. So in here, we will be having again two answers. So one is for the vertex of the parabola and the second is for the focus of the parabola. So the equation is y minus 2, the quantity squared, plus 16 times the quantity of x minus 3 is equal to 0. So our goal is to have a pattern or the one which is almost the same with our standard equations or general equations so that we can visualize it further if it is opening upward, opening downward, or opening left and right so that we can determine the different values or we can possibly graph it to determine what are those other components that we need in solving problems related to parabola or ellipse or any other conic sections. So I transform the equation. So we have here the quantity of 16 times x minus 3. So as you can see here is transposed to the other side. So that is why it is now negative 16 times x minus 3. So based on our formulas for the standard equation, so the one which is almost the same with this equation is the one which is opening to the left. So for the parabola opening to the left, so we have y minus k squared, which is equal to negative 4a times the quantity of x minus h. So from here, we can get the value of the vertex, wherein the value of the vertex is hk. So again, since negative h is equal to negative 3, so the value of h is equal to 3. And then negative k is equal to negative 2, so the value of the vertex is, or the y coordinate of our vertex is 2. So we now have the final answer for the vertex, which is 3, 2. And now we will be focusing on the value of the focus of the parabola. So now that we know the vertex, so we can also note that the value of 4a is the latus rectum. So the 4a is 16, wherein 4a is equal to 16, a is equal to 4. So we now know what is the value of the focal length, which is vital in graphing the parabola and determining the value or the coordinates of the focus. So we will be proceeding with the picture or the image of the graph so that you can visualize or you can graph your other parabolas further also. So we have here the graph of the parabola, so the equation that we provided earlier. So as you can see here, the vertex that we have is 3, 2. So by graphing that, so we have here to count 1, 0, 1, 2, and then 3, and then 2. So we have here 3, 2. So here's the vertex. So as you can see here. So this is the vertex 3, 2. And then the value of our focal length A is equal to 4. So since we know, or based on our equation, we have a parabola opening to the left. So you can randomly graph something or parabola which is opening to the left so that you will know that in order to find the focus, so you will just have to count to the left 4 counts since the value of your focal length is 4. So since the value of the focal length is 4, so count 1, 2, 3, 4. So this is 4. So this is the value of the focus of the parabola, so which is negative 1, 2. So here's the focus of the parabola based on the graph. So you must know how to graph a parabola. And then if you want to accurately graph, or if you are asked to accurately graph the parabola, so you know that the value of the latus rectum is 16. So you have to count from this focus to the other, or the value of the latus rectum on this side or on this line is 16. So for example, here lies your latus rectum 1, and then here lies your latus rectum 2. So your graph or your parabola must pass through the latus rectum and in here. So again, the length of your latus rectum here is 16. So since this is your focus, so the length of your latus rectum here, latus rectum to the focus is 8, or and then from the focus again to the other side of the latus rectum is 8, since the total length is 16. So again, we have another property which is directrix or directrices. So for the parabola, so we only have one directrix, so which is same distance with the focal length, or from the vertex to the focus. So that is the same distance from the vertex to the directrix, but you will be having it on the other side. So for example, we count here from the vertex to the focus to the left, so you will be counting from the vertex to the directrix to the right. So the location of your directrix is, just count for 1, 2, 3, and 4. So your directrix is here, which is a straight line. So this is supposed to be a straight line. So this equation is equal to x is equal to 7, or x minus 7 is equal to 0. So that is all about the parabola. But for this problem, the answer is the vertex, which is 3, 2, and the focus is negative 1, 2. So I just introduced, just in case you were asked to graph an accurate graph and to determine the latus rectum and the equation of the directrix. The last sample problem that we have here is focusing more about the ellipse. So again, we have here question wherein we are asked with two final answers, so the center and vertices. So the equation provided here is 4x squared plus 9y squared minus 24x plus 72y plus 144 is equal to 0. So this equation is in general equation. As you can see, this is in an ellipse also, wherein A is not equal to C. So again, my recommendation is to achieve the standard equation, since our standard equation possesses different components such as the value of A, the value of B, the center, HK, so that we will be able to answer the question, since we are looking for the center and then the vertices of the ellipse. So our goal is to achieve the standard form of the equation. And how can we do that? So first of all, I suggest you combine the same variable, so x, and then you combine the same variables with y, and then put the constant on the other side of the equation. So 144 is the only constant, so you have to put it on the other side as negative 144. And then it is proper to put parentheses so that your solution is very organized, so that you can determine or you can properly solve, since we will be utilizing the concept of the completing the square, which is very applicable in solving quadratic equations. So as you can see here in completing the square, so it is a must that you put blanks, since you will be adding a specific constant, and then once you add it to the other side of the equation, it is a must that you add it to the other side of the equation also. So if possible, so kindly factor your equation, because that will also add convenience in solving or in completing the square, or in application of completing the square in quadratic equations. So as you can see here, so we have here our equation, which is we factor out 4, the common factor. And then we have here 4 times the quantity of x squared minus 6x plus blank, in which that is what we will be solving later on. And then we have here 9 times the quantity of y squared plus 8y plus blank also is equal to negative 144, plus the one that you will be adding to the first equation, and then the one that you will be adding to the second equation. So as you can see here, it is easier to perform completing the square, since the equation, the coefficient of x squared and y squared is 1. So we will just be doing the b over 2a squared, wherein the value of b for the first equation is negative 6, and then the value of a is 1. So b, negative 6 over 2 times 1 is negative 3 squared. So that is 9, as you can see here, already added. And then we have here 8 divided by 2 is 4 squared. So that is 60. So already added. And then we have here the blank. So take note that you factor out 4 here, and then you added 9. So that means you still need to multiply 9 by 4 before adding it to the other side of the equation. So we have here 9 times 4 is 36. So the same as with this 16. So the 16 is you still need to multiply it to 9. So 16 times 9 is 144 before adding it to the other side of the equation. So we have here the simplified equation is 4 times x squared minus 6x plus 9 times the quantity of y squared plus 8y plus 16 is equal to 36. So we will further simplify it. So let us proceed to the next slide. So as you can see here, we can also simplify or put denominator 1 since that is almost the case. So that our goal is the left side of the equation. As you can see, negative 144 plus 36 plus positive 144 is equal to 36. So the goal is to achieve the standard equation wherein the constant on the other side of the equation is 1. So we divide the entire equation by 1, as you can see, by 36, sorry. So the entire equation was divided by 36, so that 36 over 36 is equal to 1. So as you can see, the entire equation here is multiplied by 1 over 36 or simply divided by 36. So we have here 4 over 36 is 9. You just copy the equation provided. And then 9 times 36 or 9 divided by 36 is 4. And then 36 times 1 over 36 or technically 36 over 36 is equal to 1. And then we can factor the numerator. So the x squared minus 6x plus 9 is x minus 3 squared. And then y squared, take note of that. So the y squared plus 8y plus 16 is equal to y plus 4 or the quantity of y plus 4 squared. So based on this equation, we achieve the standard equation wherein we can get the value of the vertex hk or the center. Since negative h is equal to negative 3, so h is equal to 3, and then negative k is equal to positive 4, so the value of k is negative 4. So since part of the question is to find the center, so we now have the answer for that, which is 3 and negative 4. And based on this equation, we have two important parts: the half value of the major axis, which is a squared is equal to 9, so a is equal to 3. And then b squared is equal to 4, so the half value or half the value of the minor axis is equal to 2. So with these components, we can now graph the ellipse and then we will be determining the vertices. Here's the graph of our equation provided. So as you can see here, we have the value, or first of all, we inputted the center, which is at 3. So we have here 1, 2, 3, negative 4. So 2, negative 4. So here's our center. And take note, we have the value of A or half the major axis at 3. So that is 3. So you just count 3 to the left. So 1, 2, and then 3. And then here's your first vertex or first vertex. And then count 3 to the right. So we have here 1, 2, 1, 2, 1, 2, 3. So here's your second vertex. So we can now determine the value of the vertex. So obviously that is 0, negative 4, and then 6, negative 4 based on the graph. So as you can see here, these dots, so I will just be changing color. So I will be changing color this to red. So these dots are the dots of the focus or the foci. So how to get that? So since you have the value of A and B, so you can get the value of C. So the value of A is 3 squared, so that is 9. And then the value of B is 4. So 9 minus 4 is equal to 5. So c squared is equal to 5, or c is simply the square root of 5, or around 2 point something, 2.5, 2.25. So you can graph that. So from the vertices, or from the center, so I will just be changing color. So here's the center, yellow. I think yellow is not. So here's the center, which is 3, negative 4. And then you have to count the value of the c. So the value of the c is square root of 5. So from the left, so that is around 2 point something. So 1, 2.5, I think, or 2.25. So here's the location of your focus. And then count the square root of 5, another value of the square root of 5 to the right. So you have here another focus. And the location of the focus, so you draw a straight line. So here's your latus rectum. And then here's your latus rectum. So again, the value of the latus rectum for ellipse is 2b squared over a. And for ellipse, we have two directrices, unlike the parabola wherein one lang siya. So I've mentioned about the directrices. So since you have the value of C and A, so you can find the value of the eccentricity, wherein also there is a relationship for the directrices and eccentricity. So you can find the value of the directrix. So if you find the value of the directrix, so you just have to put it, so from the vertex or from the center. So that is quite a lot of misconception and of the vertex and the center. So since we are just talking about, in parabola, we are talking about vertex only. In ellipse, we are talking about center and vertex. In circle, we are talking about center only. So in ellipse, we have here the center. And then once you got the value of the directrix, so you just have to graph it. So from to the left. So this is just an example. So to the left. So suppose this is a straight line. So again, I am using my right hand. So I am a left-handed and I am using a mouse to draw this line. And then to the right. So a straight line. So this is the directrix. So again, we have two directrices in ellipse. So compared to parabola na only one. So you have to manipulate the different formulas and as much as possible graph so that you can determine if your answer is right or wrong. So that is all for today. Hopefully this video is enough to about the topic conic sections. And again, if you wish to have a copy of this PowerPoint presentation and the module about conic sections, so just email me at ryannicole05@gmail.com. So thank you very much for today. So hopefully I can continue making up videos about mathematics and mechanical engineering subjects. Thank you very much for today. Bye-bye!